Here we go. Chapter 13 is all about water and water resources and our use of water. The case study surrounds the Colorado River. The Colorado River flows 2,300 kilometers through 7 US states. It includes 14 dams and reservoirs. Water is supplied mostly from snowmelt from the Rocky Mountains, and it supplies water and electricity for about 40 million people. So these are major cities: Las Vegas, Phoenix, Los Angeles, and San Diego. And it irrigates crops along the way that help feed America. However, there are a lot of issues with this particular river. There really is very little water that's reaching the Gulf of California, which is where the Colorado River ends. This system has experienced severe drought since 1999. Lake Mead actually fell to record low levels in 2015. This is the watershed. This is the Colorado River Basin. You can see that there are two general areas, the upper basin and the lower basin. And everywhere where there's like a little dark green C-shaped um, um, icon, that's a dam. And then the red lines that you see down in LA, Palm Springs, San Diego, all that's aqueduct or canaled river basin that has been dredged and kind of like poured in place. So it's not meandering, it's not natural. There's not a lot of sediment that settles there because there's not a lot of friction. So it's like, like a concrete channel. And because it's been channelized, it does not really act like a natural river basin. So this is what the Colorado River looks like. You ever heard of the Grand Canyon? The Colorado River actually has carved the Grand Canyon. So it's a really, really large river. And one of the interesting social aspects that comes out of using this water is the salinization of the Colorado River, that the water is used for agricultural purposes along the way, and then it's reintroduced into the stream flow. But once it is used within agriculture and then reintroduced, there's a lot of salt that's added along the way. So as it moves from north to south, it actually increases in salt. And the volume of the flow is really low by the time it reaches the Gulf of California. So you can kind of see geologically or geographically that there is the Gulf of California is between like the mainland Mexico and Baja California, which is part of Mexico. That Gulf is where the river should actually terminate. That's the headwaters. But there's not a lot of flow there. We'll kind of get into. I actually have a wonderful video to show you a little bit later on that one. So the big question when we're looking at fresh water is, will we have enough usable water for all the needs, all of like our human societal needs? So fresh water, which is one of the most important forms of natural capital. I talked about natural capital, or it's like the riches that we have that just come from nature themselves. If we don't preserve natural capital, and then we have to figure out some technological way to supply whatever it is that natural capital is supplying to us. So fresh water, obviously. If we have to use salinization or desalinization, or we have to use filtration and storage of water, there's a lot of cost that goes into that. So the thing about fresh water is it is pretty inefficiently used. It's highly polluted. And because it is low cost, it really doesn't discourage waste. So if it doesn't discourage waste, it encourages waste. And it's not accessible to many people in the world. Freshwater has an irreplaceable component. It is something that we kind of like rely on instinctually. But as we are using our water resources and contaminating or pulling water out of the ground faster than it can be replenished, we are learning as a society that there is a cost to poor management of our water resources. So this is definitely an economic issue because water is vital for producing food and energy. It's a national and global security issue. People have gone to war many times over access to water. And it's an environmental issue because with excessive withdrawal of water, we are reshaping landscapes and we are reshaping ecosystems. Most of Earth's freshwater is actually not available to us. Freshwater availability is at 0.024% of the water supply, like collectively. So, freshwater we find in groundwater, in lakes, in rivers, and streams. It's part of the hydrologic cycle. Hydrologic cycle, remember we talked about that in the FRQ when I was asking you just to speak to the hydrology of water. You're only dealing with water movement. So movement of water between the land, sea, and air. Water is definitely distributed unevenly, and humans have a tendency to alter the hydrologic cycle as we look for ways to store water, divert water, and use or pump or move or pull water out of places where it's held in a hydrologic sink. This can really disrupt ecological systems because the cool thing about water is when there is a lot of water in a space, it kind of like creates its own weather. So this picture is just really to symbolize and bring home the importance of freshwater in societies. We talked about 40% of the world's population living basically at or below an abject poverty line, right? And one of the factors that determines whether someone lives in poverty or not is their access to fresh water. And basically looking at how much time and effort in their day of work is spent basically fetching fresh water, making sure that they have water available. So there's a few different terms that you need to associate with the availability of water, especially surrounding groundwater and surface water, as these are really critical resources to human societies. The zone of saturation is a space is like within groundwater, spaces in soil below a certain depth that are actually filled with water. The water table is the top of that zone of saturation, and an aquifer is an area where water will be stored in the ground. These are recharged naturally by precipitation or nearby lakes, rivers, and streams. But it is a geologic feature of the land where the soil actually holds onto water, and there is basically like a body of water under the ground. So between groundwater and surface water basically is all of the runoff. It's the watershed, which another term for that is a drainage basin. So everything that would run over the earth. Those are really critical water resources. So you can see here the diagram shows precipitation. It shows evaporation or evapotranspirations coming off of plants, evaporation off of surface collected surface water like in a lake or a pond or things. All of this counts as ground and surface water, and this is all an aspect of the hydrologic cycle that we really find to be something we call our like reliable runoff. So 2/3 of surface runoff is lost to seasonal floods. The rest of that we would call reliable runoff. This is the remaining 1/3. This is the source of our fresh water. Worldwide averages use this water in different ways. So irrigation for crops and livestock is 70% of this fresh water, this reliable runoff. Industrial use is 20%, and then cities and residences use about 10% of that. So I know we talked a lot about land use in the last chapter, and we talked about the production of food, raising crops, raising livestock, and how much of an impact on the environment our collective organization of raising food really does, what it really does for the environment, and water is one of the components of that. So you can see our virtual water use. You can kind of take a look at something that might sound familiar. About 40 gallons is about a bathtub full of water. And this is looking at common household or daily items that like your water use can kind of offset. So how many tubs of water, how many 40-gallon units of water does it take to produce a hamburger? About 12 tubs of water. And that goes into like what goes into the crops, and then what goes into the feedlot, and what goes into harvesting the crops to feed the beef, and how about harvesting the beef and packaging the beef, and everything, that all the water that it can requires in that whole process is basically kind of calculated in this comparison, a lot like a footprint, like we talk about carbon footprint. This idea of virtual water, like how much water is actually used to produce these things in your life. So it kind of puts in perspective like how much water is required. I'll tell you this much: I love coffee. I'm a total coffee drinker, but it's actually better efficiency water wise to drink tea. Eesh. Um, Freshwater resources in the United States do go to particular industries. You can see that electrical power and plant cooling uses a lot of water. Irrigation uses a lot of water. The public water supply is much smaller than those two things together. Industry, livestock production, and then over on the right hand side, it's talking about like personal use. So in your household daily use, where is water being distributed? How is it being used? This is a very uneven distribution. We actually don't use that much residentially, but even then, we have the capacity to reduce the amount of water that we are using. All right, going to click through some of these here. So, understanding this like rough measure of all the water you use as an individual it gives you kind of a sense of the scarcity and the preciousness that water is as a resource. Virtual water is something that you can use to understand how that's going to impact society. All right. So, one of the things we look at, just like with food, is as population increases and as the demand for water within industrialized situations increases, that water shortages are also going to increase. Not to mention, climate change does feed in to those water shortages. Many of the world's major river systems are highly stressed. So, the Nile, the Jordan, the Yangtze, and the Ganges River are all have a shortage of supply. More than 30 countries currently are facing freshwater scarcity. This is estimated to grow by 2050. When you look at a budget, much like money, if we are using water faster than it can recharge the areas that it is naturally being stored, then we're going to run out in a certain amount of time. So when we look at those industrial processes that are being employed to produce our food, it's really important to look at the efficient use of water and introduce ways that we can technologically reduce the amount of water that is required to produce those amounts of food. So 30% of the Earth's land area experiences severe drought. Research predicts because of climate change that this will only worsen over time. And so we need to respond in ways that is really actually going to sustain water as a resource.